On this page, we talk about you have to watch out for you when you use multiple hypothesis tests that you might get a type 1 error on accident. Because in general, if the null hypothesis is true, the significance level gives the probability of making a type 1 error. If we conduct a large number of hypothesis tests using the same null hypothesis, then a type 1 error will occur in a predictable percentage, alpha percent, whatever alpha is, of the hypothesis test. This is a problem. If we run one hypothesis test and the data is significant at the 5% level, we have reasonably good evidence that the alternative hypothesis is true. If we run 20 hypothesis tests and the data in one of the tests is significant at the 5% level, it doesn't tell us anything. We expect 5% of the tests, in other words, 1 in 20, to show significant results just due to chance. This is an important point because we need to be aware of situations in which a hypothesis test has been performed a large number of times until a statistically significant result is obtained. That statistically significant result is probably a type 1 error. For example, we'll talk about cell phones and brain cancer now. The following is an excerpt from the 1999 New York Times article titled Cell Phone Questions But No Answers, as referenced by David S. Moore in Basic Practice of Statistics. He says, a hospital study that compared brain cancer patients with a similar group without brain cancer found no statistically significant association between cell phone use and a group of brain cancers known as gliomas. But when 20 types of glioma were considered separately, an association was found between cell phone use and one rare form. Puzzlingly, though, this risk appeared to decrease rather than increase with greater mobile phone use. This is an example of a probable type 1 error. Notice that the hypothesis test is performed 20 times. Suppose we conducted 20 hypothesis tests with the null hypothesis, cell phone use is not associated with cancer at the 5% level. Then we would expect 1 in 20 or 5% to give significant results by chance alone when there is no association between cell phone use and cancer. So the conclusion that one type of cancer is related to cell phone use is probably just a result of random chance and not an indication of an association. Now look at this little cartoon. It says, the first cell says, jelly beans cause acne. The person on the left says, jelly beans cause acne. And then the person on the right says, scientists investigate, but we're playing Minecraft. Ah, fine. The scientist said, we found no link between jelly beans and acne with a probability or a sample proportion of 0.05, greater than 0.05. And the original first people talking says, that settles that. I hear it's only a certain color that causes it. Jelly beans. Scientists. They're asking scientists, can you look at this, a certain color? And they're saying, but Minecraft. They want to play a game instead of looking this up. And then they look it up. Okay. We found no link between purple jelly beans and acne. The same sample proportion. Also, we found no link between brown jelly beans and acne. Also, we found no link between pink jelly beans and acne. Blue jelly beans and acne, no link. Lastly, teal jelly beans and acne. Oh, then salmon jelly beans, red jelly beans, turquoise jelly beans, magenta jelly beans, yellow jelly beans, all these, supposedly there's no link between them and acne. Okay, how about, and then they get to more colors. Okay, there's gray, are there really gray jelly beans? Gray jelly beans, tan jelly beans, cyan, is that some kind of blue? We found a link between green jelly beans and acne with P less than 0.05. Finally, a statistically significant result. Whoa, green jelly beans do cause acne, but really it's just random chance that probably made it so that they got the results they did. That's kind of silly.